Hi there. Here we are, section 9.5, hypothesis testing for a population proportion. There are so many P's in this section, you will be shocked. So just deal with it. So we're on page 478, and I'm looking at question number 31, ethnic Asians in California. So the question reads, a report states that 12.3% of California residents, or Californians, were of Asian ethnicity. Suppose that a random sample of 400 California residents yields 52 of Asian ethnicity. We are interested in whether the proportion of California residents of Asian ethnicity has risen. So among all this kind of blah blah of words, this is important. Has risen. We want to know if the proportion is getting bigger. So part A, is it appropriate to perform a z-test for population proportions? Why or why not? So what this question is asking, here it is again, is here's the rule. Here is the rule. Let me make my pen nice and big. We can only use this test if n times p0 is greater than or equal to 5 and n times 1 minus p0 is greater than or equal to 5. This means if these conditions are met, then the sample proportion has an approximately normal distribution and we can use the z-test. So we have to kind of dig around in this information and find our p0, which is the proportion in the null hypothesis. And in this case, p0 equals 0.123, because that is the proportion that it used to be, and we're interested in whether or not it's getting bigger, so bigger than that. N equals 400. And again, think of it this way. P, which is equal to the current, or like, so this one was from 2005. So this, we're interested in the proportion of California residents of Asian ethnicity. I'm going to say Californian Asians, even though that's not accurate, but it saves me a little space now. So we want to know, I have to, sometimes for these problems, in order to find n and p0, you have to work into the problem a little bit. So we want to know if the proportion has gotten bigger than 0.123. So we are interested in whether the proportion has risen. So the alternative hypothesis is p greater than 1.3, and the null hypothesis is p equal to 0.123. Why did I write these down when the question was only asking me about this? It's because I needed this p0, and I wanted to show you very clearly where it comes from. It comes from the proportion that's in the null and alternative hypothesis. So we want to test 400, that's our sample size, times 0.123. That's equal to, wait for it, 49.2. Why, that is bigger than 5. Check. We also want 400 times 1 minus 0.123. So that's n times 1 minus p0. We want that bigger than 5. That is 350.8. Ladies and gentlemen, that number is bigger than 5. So we are good to go. We are good. So yes, it is appropriate to answer this question. Yes, we can use a z-test. And that is because n times p0 is bigger than 5 and n times 1 minus p0 is bigger than 5. Okay, now we're going to move on to the next part of this question. How many standard errors does p hat lie above p0? Why or why not? Here's the answer. Don't do this part. This question I don't think is that helpful in the scheme of hypothesis testing. I'd rather that you know how to do the hypothesis test and not worry about how many standard errors p hat lies above p0. So let's skip this part and move on to part C. So this is the meat of the question. I want you to be able to do a problem like this. Is there evidence that the population proportion of California residents of Asian ethnicity has risen since 2005? Test at the alpha equals 0.05 level. Again, when you see this alpha level, that's your big tip-off that you are doing a hypothesis test. Okay, I'm going to clear my paint picture. Hold on. Okay, problem. And again, we're looking for evidence that the population proportion of California residents of Asian ethnicity has risen since 2005. And again, I like to write, as I do on the hypothesis test for a mean, I like to make a little notes on the margin about what some of these things are. So, first thing, what is the population proportion that we are testing? P equals the proportion of Californians who are of Asian ethnicity. So I'm going to write proportion of Californian Asians to save space. And that's now as opposed to in 2003. So you want to write the null and alternative hypothesis. To get full credit on a test, you need these null and alternative hypothesis. We want to test if it has risen. So this is P greater than the previous one, which was 0.123. So 12.3% is 0.123. And then this one's always, the null hypothesis is always equal to 0.123. Okay, making little notes here. Random sample of 400, n equals 400, yields 52 of Asian ethnicity. So if you're using your calculator, the calculator considers like the count, x, is equal to 52. That's how many like successes you had, how many Asian Californians out of 400. It was 52. The sample proportion is 52 out of 400, which is equal to 0.13, I believe. And then what other information do we need? With the alpha level is 0.05. You'll notice paint, I have to write the word alpha because it can't take the little Greek symbol. So we've got the null hypothesis, alternative hypothesis. Now we need the test statistic. So the Z data has this confusing, I'll show it to you. It's right here. Yep, so we did this right here. This is the formula for the test statistic. It's p hat minus p0 square root divided by the square root of p0 times 1 minus p0 all divided by n. And because I'm doing this on a video, I'll do this all for you. This is square root, on the very top, p hat. So 0.13 minus p0. p0 equals 0.123. 0.123, all divided by, on the bottom, you'll notice it's p zeros, so you have to be a little careful if you're doing this by hand. So the p0 is 0.123 times 1 minus 0.123, all divided by n, which is 400, which is equal to, when everything is said and done, I think it was 0.44. Where's my picture? Sorry guys, 0.426. I will check that. Okay, so there's your Z data. Now you need a p-value. In order to make a conclusion, you have to know what is the probability of getting this test statistic. So really, the easiest way to do this is on the calculator. I'll show you how to do this on the calculator. On your calculator, the rules, if you want to go through this in the book, is on page 476. So you go to Stat, right? Stat button, and then you arrow over to Tests, and then you go down to 5, which is 1 proportion Z, and then hit Enter. The cool thing, look at this, that's section 9.5, and it's number 5. How nice is that? So now your P0, that's 0.123, because that's the number that was in the hypothesis. X, that's the count. Right? That was the number of people out of your sample of 400 that were Asian Californians. N is 400. And this next line, that's the alternative hypothesis. So if you look here, the alternative is greater than. So you want to highlight the greater than one. So make sure you highlight this one. You'll get the wrong answer if you highlight the wrong alternative hypothesis. And then you can hit calculate or draw. I usually pick calculate because I don't need a picture. And this is what it gives you. The calculator gives you lots of helpful things and many, many p's, the letter P. So the proportion, which is 0.123, you knew that. That was from the alternative hypothesis. And then it says Z equals 0.426. Okay, that's your test statistic. And it says P equals 0.3349. That's your p-value. Then P hat, that's the sample proportion. See what I mean about all the p's? That's 52 out of 400. Right? And then n is 400. So, here we go. So let's go back to our picture. P-value is 0.3349. As an aside, you could do this, make it in red. If you didn't have the calculator, you would have to find the p-value like this. This is a z-table. You found your test statistic. That's 0.43. The p-value is this area, right? That. The table gives you this area, so the table, if you look up 0.43, most of you are not doing this, you guys. So if you're thinking, why is she doing this? I don't know why I'm doing this. Don't do it this way. Do it on your calculator. 0.43 gives you 0.664. Just showing you. 0.6664. So that area is 1 minus 0.6664, which is equal to 0.3336, which is what we got from the calculator. So let's just do the calculator way. So now we have the z data, the p-value. We need our conclusion. Remember, this is always the rule. Reject H0 if the p-value is less than the alpha level. So in our case, we have the p-value. This is how I like to write it. P-value equals 0.3349. The alpha level is 0.05. This number is bigger, is greater than the alpha level, equal to 0.05. So we would reject if it was smaller, but it's bigger, so we fail to reject. Your paper won't have this much space on it. So, fail to reject. Write your conclusion like this. Fail to reject H0. Now you must include a sentence that puts the conclusion in terms of the problem. There is insufficient evidence to conclude that the population proportion of Californians of Asian ethnicity has risen or is greater than 0.123. So again, here are the pieces that you want to put on your test. You want the null and alternative hypothesis. You want to say what the test statistic is. Z data equals 0.426. You do not need to write this down unless you are using it and not your calculator. You need to write down the p-value. You need to write this sentence. The p-value is greater than the alpha level, so we fail to reject H0. And finally, you need a sentence like this. There is insufficient evidence to conclude that the population proportion of Californians of Asian ethnicity has risen. Whew. That's all. That's all you need to do. How simple is that? I did a lot of extra writing, but that's basically all you need to do. And the calculator is your friend. Please use it.